Hello everybody and welcome back. So we are doing this. This is an FBX file here. This is, let's see, this one here. Yeah. So this is an FBX file, but it also has the children. So here you can move them. And you also notice that their pivot is where we had them in Houdini, and also the directions. So here you can see the gizmo in Unity is aiming correctly. So we're going to continue and do in Houdini in the last where we left off. And also, if you have them like this, you see now it doesn't really align. You just need to move it locally here. So maybe that confuses you, but let's go back. So we are at the moment here. So we managed to divide them. So now we have childs here. This is really good. And inside here, I just want to make it a little bit more nicer with the namings, because now the name is just 0 to 11. And what I want to do with the name, so let's see, string base name. So we're just going to do the base name like this. It's going to be the, if I do gizmo like this, now we save gizmo in base name. Now we can do base name plus name. So now you see gizmo and one and so forth. But let's do like this. We do number. I'm gonna just change this to number. It will be a little bit more tidy. And also, you can see here that if we focus on the number is equal to, let's do sprint. So what we will, if you do 0 to the underscore percentage 0 to D, and then you do the value you want to change. Now you can see it's 0, 1, 0, 0, 0, 0, 1, and so forth, and an underscore. So what I did, actually, we start like this. Now it's gizmo 0, 0, and this sprintf is actually making it to only 2 digits, because this percentage 0 to D is taking care of that. And if I just do an underscore here, now you see the naming is much more nicer. So I just wanted to address that to make it nicer. So what you notice here is that the blue arrow, that's kind of the forward direction of the gizmo. If we look at the gizmo here, and if you look at down here at the corner, you can see that forward is the blue and upward is the green one. And when you look here, it kind of it's kind of messed up because we haven't really given any directions. So we want the green one to be upwards, and the way to do that is to, if you first do a normal and we make it on the, let's see, I'm not entirely sure we need it, but I will use it anyway. So now we have normals. I just make sure that we have the normals, you can see them here. They are the same direction as the primitive. And that's going to be the upwards. So if we use a wrangler here, then we can just do v at up is equal to the normal. So now, because we're taking the normal and using that as the up direction, so now you can see that it doesn't work. Wait, is it? Okay. Before we continue, so we have the up. Yeah, actually it do work, but we need to change the normal direction because the normal and up is the same direction now. So what I want to do, if you think about the points here, and this is the center, so it's kind of a value of a direction. So each point is a direction. So 0 here, and then it's a value here. So if you think about it, if you just take the vector position and you just do normalize the position, now you made a vector, a direction of the position from the center. And if you just do the normal is equal to the position, now we kind of made them to point the same direction as the position. So now you see we kind of controlled the direction of this. So if we save now, bam, and go back to Unity, now you see them, that they are pointing like this. And now you can see that they are pointing at the same direction as well. So this is super nice. So if we just add the material to these ones like this, and if you look at this one here, so you have the blue one and red, and that's exactly what we have. So now we made sure that all the childs are up here in the transform also correct. So this is really nice. And now one thing that's a little bit irritating is you see the scale here is 100, and it doesn't really need to be a problem, but sometimes it might be a problem. So there's a way to address that too. So the thing is, it's this node down here, because if we don't use it and we do save disk, now it's really tiny. So we kind of need it, but instead of doing it at the last part here, you can just add it here. And if we save it now you see we have the scale to be 1 here. And this is great because now there's no scale difference and stuff. And so we still have our kind of main parent here, right? But we have the parents, and they are, well, childs, I mean, and they are exactly as expected. So now you have the directions correctly and everything, and the scale is correctly, and rotation. And if you forgot, here we have the pack and instance, so that's why it kind of we only have 12 primitives here, and we name them down here. So gizmos, and because we have it packed an instance and we name them here, and we also use this name, path attribute name, that's why we have exported the directions and stuff. So, and also the pivot is exactly where we want it, and the reason is because pivot location is not at the center, but it's at the origin. So this is lovely. So now we have the mesh like this. But let's say you want to just export no mesh at all. So I'm going to show you. I'm going to leave this one. So I'm going to make another one here. So this is going to be the kind of mesh export. Mesh export. So let's say you just want to export points, but you can do that. And it depends on what you mean with export only the point. But if you look, let's first just export the point, and you will understand what I'm thinking about. So if you look at this one, here we have meshes, and it's copies like this, and that's what we have here. Perfect. But now we're just going to do points. And if you do an add node here, and you just do plus, and now we have a point in the center. It's a little bit hard to see, but we have it here. And if you do like this, and I'm going to save first. I'm going to save the file. So now if we look here, we have all the points, perfect. And you see 0 to 11. And here we do naming gizmo 00 and all this stuff down here, because this is packed an instance. So it looks like we have primitives here actually. But when I click export on this one, it's going to crash. And as I see it, it's because we are actually not exporting any primitives. So a primitive includes points. And at the moment, if you look at this one, we don't have any primitives. It's just 1 point. And we pack it 12 times. And here it says prims, but it's just only packed. But if you open up this package, there is just 11 points. So this is kind of a little bit misleading. But anywho, so now we save it and it crashed. So the reason is we can't do it that way. So I'm going to open it up again. So we're back, and if I just do a grid, and this grid I do like rows, the size doesn't matter, but the point is, this is just a quad. And here you can see 1, 2, 3, 4 points. And that's what we see here. And then primitives, we have 1 primitives. But the thing is, we also have vertices. And the vertices, that's what kind of glue the points to the primitive. And so we need to address that. So here, we're going to do a wrangler. And this wrangler, we're going to do an int prim is equal to add prim. And we're going to add this prim to the 0 input. So that's this one here. And then it's going to be a poly. So now we kind of created a primitive. But we also need to attach the point to the primitive. So we do an add vertex, and we need it to be on the first input. And we're going to add a prim. On the prim, we're going to add the add pt num. So here now we have the prim. We have 1 prim. We have 1 vertex that glue the current point to that prim. And now if we do save to disk and go back here, now you see we have all the childs and everything here. And you can see actually there is mesh here, but it's only 1 point. And because of it's only 1 point, we will never ever see or render this mesh. So you can use this. Maybe you want to add, let's see, if you do like this and you add a cube, and now you can add your own stuff and only use the transform. So this is really cool, and then you can use that for different scenarios. Maybe you have a model the car and you have this sorry. So you have these special positions that you want to place your add-ons on the car. So that might be a good reason why you have this transform. But of course, if you want to be optimized, you don't want to have the mesh render at all. And the mesh filter, you kind of want to just export it like this. But you can't do that because then it crashes. So what you can do, if you go out here and then you do, if you do, let's see, so this node here, this is a transform node. So you see the transform here, rotate and scale. And if we do another one and we just do some different stuff going on here, we can scale this one up instead. So, and then if we just pack them in a container, the subnet. So if we just want to transform, we can go up to the export and FBX, and then we just do the subnet. If we pick that one, and then we need to save it. So we do the export transforms, and I think this should be okay. Export now, export transform. Now you see we have only the transform and we see the stuff here. So that's kind of tedious and manually to work like that. And I have a script that actually do that and export, streamline it. So you just have a button and then you can kind of export the mesh and transform without that one point mesh, but I'm not going to show that now because it's kind of tricky, Python and stuff. So I'm going to dedicate that to the future if it's interest or something like that for it. But I'm going to show you. So let's say now we have, I'm going to save it one more time. So now if we think about why this could be interesting, it's about the context. But one thing that you could do is that what I did here, let's see. So if you look here, I actually exported only points. So this is only points. So all these transform, they have different scales and they have different rotation and they have different position. So, and then I have this cube here and I made a script here. And if you want this stuff, you can find it on my Patreon site and you can access the script and such. And but the only thing I do, I kind of lerp between all these transform, and that could be one use case why you would like to have export only points, because you really want the super accurate positions. So this is kind of what I wanted to show you, really kind of the really good default stuff that you really want to know about the FBX exporter. So not really super interesting visual stuff, but I really think this about having different positions like this is really good to understand. And yeah. So thank you so much for watching, and I really hope you find it interesting. Actually, I'm going to show you the script. I assume that some of you want to know the script behind this one. So here we have it, and as you see, there is just the start function, and then it's this oh, I forgot the name. It's enumerator. What do you call it? I forgot. Anyhow, so in start, we start coroutine. It's a coroutine I'm thinking about. So this coroutine is while true, which means these conditions is correct. So what it does, we have this public transform parent holder. And if we look in the here, this is the parent holder. And this is the parent, and it has childs with all these transform, and the script is just picking a random child in this parent holder, and then I just lerp from the current position to the new transform place. And yeah, so it's only like 70 lines of code, and that's what makes this one jump around. And then I have this animation curve here, so I kind of offset the I value up and down. And also what I did actually, if we look here, I can use this one. So here I just put the P, because it P-scale, I just put a scale value on each point. So all the points here, they are have different P-scale. And then I just offset them upwards. So they are not at the same position. They are a little bit higher up. So whenever it jumps around, it doesn't penetrate the ground. It's kind of always landing on top. All right, everybody. Thank you so much for watching, and see you in the next tutorial.